In this question, Angie has a spherical fish tank with a diameter of 40 inches. So what this means is that her fish tank is going to look like a huge ball, and from one end to the other, it's going to be a total of 40 inches. So that means from this point all the way down to this point, that's going to be 40 inches. Well, it says that we're filling up the fish tank 20 inches. So from the bottom to about right here, that's going to be 20 inches. And then remember, from the bottom to the top, that was going to be 40 inches. Well, it looks like we're only filling this fish tank halfway, right? So our question is asking, what is the volume of the water in cubic inches? Well, that's going to be half of the volume of the entire fish tank. So as long as we find the volume of the large ball right here, cut it in half, we're good to find the volume of our water. So let's go ahead and do that. We have the formula for volume of a sphere right here, so all I have to do is plug in all my information. So I have 4 times, we'll use the approximation for pi, so 3.14 times our radius cubed. Now our diameter is 40 inches. All we have to do is divide that by 2, which is 20 inches. So that's going to be the radius. And we're cubing that, and we divide everything by 3. So on top we're going to have 4 times 3.14 times 20 cubed is 8,000. We're still all dividing by 3. So if I evaluate all this, I do 4 times 3.14 times 8,000 and divide all that by 3. I'm going to have an approximation down here. So the volume is going to be about 33,493.33. And that's inches cubed. Now remember, that's the volume of the entire sphere. We don't want that, we just want the volume of the water. So we could take this number right here, divide it by 2, and that's going to be the approximation for the volume of the water. This number is going to be 16,746.665. And again, that's going to be in inches cubed. Actually, let me rewrite this. This could be cleared up a little bit. It's 0.66. In this question, Freddie is depositing a bunch of water in this huge cylinder tank, and we want to figure out if all this water is going to overflow it, basically. So we have the radius of this cylinder tank. That's going to be 2.5 feet, and we know how much water is going to be put into that. That's going to be 410 gallons, or 54.809 cubic feet. So let's plug that information into my formula, and then we can figure out the height. So like, how tall does this cylinder have to be to fit all this water? So first off, I'm going to plug in my 54.809. I'm going to use the approximation for pi, so that will be 3.14, and then I plug in my radius, which was 2.5 feet. We're squaring that, but we don't know our height. Okay, that's what we want to figure out here, and we can solve for it. So I'm just going to rewrite this part right here. And then if I take 3.14 and multiply it by whatever 2.5 squared is, we're going to end up with 19.625 times h. And then we're going to divide this right side by that number to cross it out. So this side gets divided by that number. And we're going to be left with a height of about, and this is approximated, but it's going to be about 2.79, and that is in feet. So the volume of all this water that he's dumping in, which is 410 gallons, well, that would take up a cylinder that would have a radius of 2.5 feet and a height of 2.79 feet. So Would this overflow? Probably not, because it said that the tank that he was working with, the large cylinder tank, was taller than him. So assuming he is taller than 2.79 feet, looks like we're good to go. In this question, Andy just painted a patio deck that is 12 by 14 feet. So I'm going to go ahead and draw that out right here. So this is going to be a rectangular patio deck that is 12 by 14 feet. Okay, now it says that we want to figure out how much paint he used in square footage. And the only thing that we have to consider here, other than these dimensions, is the fact that there's a cylinder-shaped pot with a diameter of 3.5 feet that was on this patio somewhere when it got painted. So let's go ahead and draw in a cylinder shape here. And then the diameter, so from this side to this side, was 3.5. Okay, well, because that pot was right here, it didn't get painted over. So if we take the area of this entire rectangle here, the area of his whole patio, find that, and then subtract the area of this circle, we would figure out how much square footage he painted, which is kind of what I'm coloring in right here. Okay, everything except this part in the cylinder, because that flower pot was covering it up. Okay, so area of this entire deck is 12 times 14. That's going to be 168 feet squared. And then we want to figure out the area of the circle. So area of the circle is going to be pi times radius squared. So our diameter is 3.5 feet. If we divide that by 2, we could get our radius. And that's going to be 1.75. Alright, so let's go ahead and plug this number in for my radius here. So pi times 1.75, which is my radius. We're squaring that. So if we multiply pi times 1.75 squared, we're going to get about 9.61625, and that's square footage. If we wanted to take away the square footage, right, because this was a circle area that was not being painted, so if I take 168 and we subtract out 9.61625, we'll be left over with about 158.38375, and that's feet squared. So this is the area, 158, about 158 square footage. That's going to be the area that's painted, and that's how much paint that he ended up using.